When you right click and you go to Blueprint class and then you choose actor, do you know why you're doing it? And be honest with yourself. Do you know what an actor is? Why is it named actor? Or are you just doing it because that's what everyone's told you? If that's you, this video is for you. In order to answer the question, what is an actor, we need to back up a little bit. In fact, let's back up even more and talk about why I'm making this video. If you're new to game development, or like me, got most of your game development experience by using Unreal Engine, we actually learned object-oriented programming ass backwards, and you didn't even realize it. Let's start by defining a few things. One of the most fundamental things of programming is a single line of code. The most basic instruction in a program that tells a computer to perform a specific operation, like declaring a variable or calling a function. So for example, you've done this in Blueprint whenever you add a variable and then you say, I want this to be a Boolean. Or whenever you're on like the event begin play and you call an event or a custom event, that's essentially calling a function. An event and a function are very similar in how they operate. A function is like a block of code that performs a specific task. And in our case, when we're working with Unreal Engine, we're using object-oriented programming, and functions tend to be a part of a class or an object. So, for example, let's keep going back to actor for right now. When we create a custom event or a function, it is a part of a class or an object. We'll skip ahead slightly just for clarification's sake. Just so you know, an actor is a type of object. I zoomed in, that should be a lot better. A class is a blueprint or template for creating objects. Now, don't mix up Blueprint in this context versus the one in Unreal Engine. They are separate, but just understand the actual definition of Blueprint. It's like a schematic. So a class is essentially defining an object. Now, this might seem silly, but an object is an instance of a class. An object usually has a little bit more information and definition than a class. Think of it kind of like the parent to child relationship. If you don't know what that means, I'll do a quick little thing. I'm not going to go into all the details, but understand that if this is a parent object, and in this parent object, we have a variable, A, okay? A is the variable in this context. If you were to make a child of this, it would include the A. Now, the child could then further distinguish itself and have like a B and a C, but whenever you're a parent to child relationship in this context, you are just inheriting what the parent has. So a class kind of defines what an object looks like. An object kind of fills in the meat. It's an instance of a class. It's a version of a class. Now we're down to actor, a type of object that exists in the game world that's capable of having a position, rotation, and scale. Actors are the building blocks for gameplay in Unreal Engine. So the big difference between an object and an actor is its ability to exist in 3D space. Why? Because it has a transform. It has the position, the rotation, and the scale. It also includes components. So when you add a static mesh component, etc., etc., etc. So let's go back up this list, okay? We have, and we're going to go from bottom up this time, an actor, okay? It has position in 3D space. It has components. Essentially, it has a concrete existence. If we go up to object, it's the same thing, but now it lacks the ability to have specific components and a position in 3D space. Let's use what we just learned and look at some of the things that we all do in Unreal Engine. As you can see, everything in the viewport right now would be an actor. Even if it's just a static mesh, it has to be an actor. Why is that? Because it exists in 3D space. If I was to click on this random static mesh over here on the left, notice it has a transform. It has the location, the rotation, and scale. It's an actor. Okay, that's great. But can I give an example of an object? In fact, I can. Over here on the right-hand side, I'm going to go to my world settings, and I'm going to open up the selected game mode. And you'll see we have a default pawn class, which of course would be an actor. We have a HUD class. What do you think? Does the HUD exist in 3D space? Not really. You can have different widgets that are part of an actor that exists in 3D space, but the actual HUD isn't an actor. The HUD is an object. The player controller class, object. Game state, object. Player state, object. And one of the most important, if we go over to project settings and I type in game instance, obviously this is from my horror game from scratch series, but our game instance is an object. So let's continue to differentiate the two so we can understand the overall principles of what each is doing and why. Let's take a look at our door. If I go up to the door, obviously we know it's an actor now because it's in 3D space. The player needs to interact with it, so we use lines of code to produce functions that the class or object can do, and then the fact that it's an actor is because we can see it in 3D space. Think of each of these as just groups of information that travel around together. Objects. If we look at the actual blueprint for the door, on the left-hand side, you'll see we have our list of components and our list of variables. These are the sets of information that we're telling this individual object to keep within itself. That's right, I called it an object because we have to remember the parent-to-child relationship. This is an object. This is an actor. However, all actors are objects. However, all objects are bold, not unbold. All objects are not objects. All objects are not actors. This is because of the parent-to-child relationship. So let's take a look at what we're doing whenever we right-click and go to Blueprint Class. Notice what it says. You might not have ever noticed this before. Pick a parent class. Let's head to our definitions. A blueprint or template for creating objects. And then whenever we go over here and we pick one, notice, you've probably never noticed how specific the wording is here. An actor is an object that can be placed or spawned in the world. Now, obviously, they could have expanded on that, but these are very quick definitions. So whenever you click actor, you are creating a child of the parent actor that Unreal has created for you to simplify the process. A pawn is the exact same thing as an actor, but it has a couple of different features that are added to it just to simplify the process. For example, a pawn, there you go, is an actor, but it can be possessed. And look, if we go even further down, a character. A character is a type of pawn, includes the ability to walk around. So a character is a pawn, and a pawn is an actor, and an actor is an object, and an object is a class. You were using parent-to-child relationships, and you probably didn't even notice. So what is the point of having an object? And I don't mean an actor, I specifically mean an object, one that doesn't exist in 3D space. Something like the game instance. Well, these are just significantly easier to run and store in real time. So if I head over to my system and I pull out my game instance, you'll note if you look on the left-hand side under the variables, first off, there's no components, but second, it's just information. We can create lines of code that would create custom events or functions, or we can add variables. Because it doesn't exist in 3D space, we don't have a viewport, we don't have components. It's meant to store data. That's it. So you can use the game instance as a way to essentially have global variables, things that other object and actors need to access in real time. And because they don't exist within that 3D space, they persist whenever you switch levels. When you switch levels, that 3D space goes away. But the game instance exists outside of it. It's an object. It doesn't need a placement in the world. So when you switch levels, it persists. And if you're new to parent-to-child relationships, you can use this logic with your own coding. Also, if you're new to parent-to-child relationships, I highly recommend uncovering inventory systems. It's not done, but I'm working on it. But that being said, we have BP door here. If I made a child of BP door, it would inherit all of the things that I've already programmed. But I could then specify new functions, events, and variables that are specific to another type of door. You'll notice if I open BP door, all of these are empty. You'll notice that I didn't specify a door static mesh. I didn't specify a door frame. I didn't specify a door offset. All of these are empty. Why? Because now I can create children of BP door that don't have all these things specified, so I can specify them to the child and then add more if I needed to. If you remember, I even said the HUD is an object. So if we go to systems, you'll notice that I didn't make a HUD for this yet. Whoa, I was wrong. Look, object, actor, HUD. HUD is a child of actor. That's interesting. So it does exist in 3D space. You know what it is? It's probably the transform on the screen. That makes sense. It's the transform on the screen. Sorry, that was a tangent. So I hope this video helps you understand what it is you're doing when you do certain things in Unreal Engine. I'll be honest, I don't know how well this video is going to do, but it just seemed really important to me to share this information because I think a lot of us lack that understanding when most of our experience comes from Unreal Engine. Anyways, please like, comment, subscribe, and I'll see you guys in the next video.